This lesson has a very specific goal, is to get kids to discover the rule for multiplying decimals. There are a lot of lessons before this that are designed to get kids thinking about the different things that happen when you multiply decimals, the different patterns that happen, and this warm-up shows a couple of those things. For example, 1 3/10 times 2 2/10, represented with pictures when we represent one whole as a square, because in base 10 you can use a square for one whole, and then each of the 10 columns that makes it up is a tenth, and then each of the individual little blocks is a hundredth, because it takes 100 of them to make up a whole. So this is one whole and 3/10, and we need two whole groups of that. So that's the second group. And then 2/10 of a group. So 2/10 of a whole is 2/10, and 2/10 of a tenth is 2/100ths. And we do that for each of the tenths. And we end up with this picture. When we estimate, this is about 1 times 2, a little bit more than 1 times 2. So a little more than 2. When we multiply the digits, that's 13 times 22. I like using grid methods, works better for me. So 10 and 3 times 20 and 2 is 260 and 20 and 6. So that'd be 286. And then when I add these up, I get 1, 2, 3, 4, 5, 6 hundredths. 1, 2, 3, 4, 5, 6, 7, 8 tenths, and 2 wholes. So that tells me that that's where my decimal belongs, and I can add it in down here. That's one way of looking at figuring out place value and multiplying decimals. Another way is this, where you say the number 1 and 21 hundredths, and because it's in hundredths, you make your lowest place value on a place value chart hundredths. And then above hundredths you have tenths, and above tenths you have ones, and above ones you have tens. So then, since we're using a place value chart, I can ignore the decimal and just multiply normally. 121 times 8 would be 968, but it's not 968 ones, it's 968 hundredths, because that's what we're dealing with. So we put that in like this, and the decimal always goes between the ones place and the tenths place, so it's 9 and 68 hundredths. Similarly, this is 3/10 times 13, so you're dealing with tenths. Tenths, ones, tens, hundreds. Put in a decimal, and then multiply. 13 times 3 is 39, so 39. So your answer is 3 and 9/10. So the objective was that we would identify a rule for multiplying with decimals. We didn't end up making it to the exit card, at least not in 4th, 5th, and 6th period. It just took a little bit longer to get through the lesson and make sure that everyone understood everything. This is the homework review. I'm just going to flash through it quickly, because you can always pause the video and take a closer look. Okay, just to check your work. And on to the lesson. So, the essential idea for this lesson, the concept that I really want students to walk away with, is that digits being multiplied behave the same way regardless of place value. This is different than with addition, where you have to line up the place values in order to get the correct answer. And we're going to see how that works on the next couple of slides. So if you have $2.32, which I'm going to represent with symbols. A square is $1, a line is 10 cents, and a circle is a penny, or 1 cent. I can do $2.32 times 5 by making 5 groups of $2.32. But $2.32 plus 5, well, first of all, plus 5 what? I can't say plus 5 puppies, because then I don't have a common number, like a combined number. I just have $2.32 and 5 puppies. And soon I might not have $2.32 because the puppies might eat it. So units are important for addition. Money and money makes money, so they should both be money. I could do 5 cents or $5. I'm going to do $5. So $2.32 plus $5 would look like this. $2.30, 2 cents, plus $5. When I add that to 32 plus $5, notice I lined the dollars up with the dollars because place value is important. So even though I didn't put 0.00 here, I lined it up here. My answer then is $7.32. Now for this one, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 cents. And then I have 10, 20, 30, 40, 50, 60, 70, 80, 90, $1. 1, 2, 3, 4, 5, $1.50. And then I have 1, 2, 3, 4, 5, 6, 7, 8, 9, $10. So 10 and 1 makes 11. And 50 and 10 makes 60. $11.60. I can also do that with grid multiplication, or you can use lattice or any other method. I like grid because it breaks it up like this, but it's still relatively quick. So that would be $2.30 and 2 cents times 5. So 5 times 2 is 10. 5 times 30 cents is going to be 150 cents, which is $1.50. And 2 times 5 is 10 cents. Same thing I got up here. And then I just add it up and I get $11.60. When we move here, we're going to start seeing more of the pattern that we're looking for, because this is $23.20. So it's still 232, but now instead of 232, it's 2320. Still times 5. 2320 plus 5. I added a new symbol, a star, for $10. And what I have is 2320 plus $5 is going to give me 2320 plus $5. The dollars still line up. Okay, you can see from the picture that the only thing that changes is we add more squares, more dollars, so everything else stays the same. So it's going to be 28.20. So $28.20. Over here, I had a couple of students say, well, how do I fit this in the grid? I only have 3 spaces here because you can do $20 and $3 and 20 cents, and there's no pennies, so I don't need a space for pennies. That's one of the cool things about grid method. You can leave out if you don't have one of the numbers. Even in the middle of a number, you could leave it out. And that's 5. So 5 20s is $100. 5 3s is $15. And 5 times 20 cents is $1. That's even easier to add. It's 116. So we start to look at the pattern here. It's 5 times 232 is 1160. 5 times 2320 is 116. $5 plus 232 is 732, and $5 plus 2320 is 2820. And I asked students, what do you notice about the difference between the answers to the multiplication problems versus the addition problems? And I make it specific. What do these have in common that these do not have in common? And students usually, somebody gets to, well, this one has the same numbers, but the decimal's in a different place. So when you multiply, let me pause this and get it written down to save some time. So when you multiply the same digits, the digits in the answer are going to be the same, even if the place value changes. So these are the same digits in both, but the place value changed. And remember, 0 is just a placeholder, so you don't even really have to think of it as a digit unless one gets randomly put in the middle. If that happens, then you're changing the order of the digits, so your answer will be a little different. So the digits in the answers are the same too, but the decimal's in a different place, and we might add some zeros to the beginning or the end. But here, we change the place value, same digits, different place value, and the answer is completely different. It goes from 732 to 2820. Different digits. Also, when you're adding, both numbers have to be the same unit. I discussed this earlier when I was talking about puppies. My students are like, why do you keep talking about puppies? That's weird. Alright? But when you're multiplying, the unit only matters for one number. So I can have 5 groups of money, and the groups are the unit almost. But if I'm adding, then both of the groups have to be the same unit, or else it's not really an addition problem anymore. So you can add money to get money, but if you add floss to unicorns, you're still going to have floss and unicorns. Then we go over step-by-step decimal multiplication and kind of condense some of the things that we've learned so far. And the first step is to go ahead and estimate. Some of this can get a little bit tricky, because like for the example, this would round to 3, and this would round to 0, but it's not going to be 3 times 0, because that's just 0. What we do know is that it's less than 1. In fact, it's less than half, because half would be 0.5, so it's less than half. Alright, so less than half of 3. Well, if about half of 3.48, so half of 3 is 1.5, then my answer should be less than 1.5, less than, especially since this is much less than a half, 10 times less, almost. So then I'd go with my next step, which is to just go ahead and multiply the digits and ignore a place value for this. If you use grid method, like I do, even if there's like a 0 in the middle, you can just kind of skip that one, as long as you, let me clarify. When I say ignore place value, I'm not talking about just multiply 3 times 5 and 3 times 6 and each number as a 1. What I mean is take out the numbers and treat them like they were in the ones, they were all dealing with ones. So like 348 ones and 56 ones. So when you're ignoring place value, you're still, this one's still 10 times bigger than this one, and this one's still 10 times bigger than this one. It's just that I'm not treating it as 3 ones and 48 hundreds, I'm treating it as 348. Because that's what we grow up learning to multiply, and it's easier to deal with in our heads. So for grid method, like I like to use, this would be 300 and 40 and 8. This would be 50 and 6. You can use whatever method if you are more comfortable with lattice or the standard algorithm. If you draw pictures, whatever you do, that's fine. This one just works for me because I can do 3 times 5 is 15 with 1, 2, 3 zeros. 5 times 4 is 20 with 1, 2 zeros. 8 times 5 is 40 with 1 extra zero, and that's 18 with 2 zeros, and 24 with a 0, and 48. And when I add here, I get 15,000 and 2,000 makes 17,000 and 400. 17,400. I'm going to add this one backwards because it's going to get a little more complicated. It's 48 and 240 would make 288. And 1800 plus 288, while 800 and 200 makes 10, or 1,000 makes 1,000. So I'm going to have 2,000, no hundreds, and then my 88 that I had from before. So that's 2,088. You can actually add them up in a column if it makes you more comfortable. 240 and 48. I've always been pretty good with adding up 10 pairs in my head, so I just do it in my head, but if it makes you more comfortable to do it this way, oops, what did I do that for? I did 8 in my head, it just came out as a 4 on the screen. Anyway, 2,088. So nothing in 8 is 8, nothing in 8 is 8, 4 and nothing is 4, 7 and 2 is 9, and 1. Then your next step is to use your estimate to place your decimal. And I purposely used a more tricky one for the example. Most of the homework ones are easier. A couple of them are a little more difficult, but most are fairly simple. This one is complicated because you have to know that it's less than half, so you have to figure out half of 3 and know that's going to be even less than that. So I put my digits in. My digits in my answer are 1, 9, 4, 8, 8, but then I need to figure out where the decimal goes. So if half of 3 is 1.5 and it needs to be less than that, 1.9 would be too big. So it needs to be less than that, so my decimal is going to have to go out here. It's going to have to be 0.19488. That's 19,488 hundred thousandths. Whoa. And I also mention, because some kids will remember it, that you can still use the old classic rule of counting. There's 1, 2, 3 decimal places here, plus 1, 2 decimal places here makes 5 decimal places. So that means that there will be 5 decimal places in my answer. 1, 2, 3, 4, 5. The only reason I don't like this is because if kids make a mistake doing this and they haven't used the estimate, then they're not going to realize when their answer is completely off. The estimate is really important for checking your work because it helps you if you type something into a calculator wrong, or if you, for instance, multiplied 340 times 2 and just ignored the 0 and got 68, and you needed a decimal place, you left off the 0, so you put the decimal place in the middle. But when you estimate, you know that this is 2 340s, so it's going to be bigger than 340. It's going to be like 600 something. So, or I'm sorry. And if it's times 0.2, then it's going to be less than 1 340, but not that much less. And your estimates are important for making sure that you can check your work and that it makes logical sense. So if you memorize the rule, that's great. Just keep that estimate in your head. Very important part of math. some practice problems. Just to show, like, this is an easier example. This is 2.4 times 6.8. If I round this to 2 times 7, then my answer is going to be somewhere around 14. And then I do the math. I treat this as 20 and 4 times 60 and 8. And I get 1200. And let me do these in a different color so that we can see that the difference between the two. 1200, 240, 160, and 32. So this is 1440. And that is 192. And that gives me 1632. So the digits are 1632. And I need something close to 14, so I just put my decimal in the middle because 16.32 is pretty close to 14. Certainly closer than 1.632 or 163.2. Next, for this one, this is less than half of 32. Barely less than half, because half would be 0.5. So half of 32 would be 16. So my answer is going to be really close to 16. So when I do 30 and 2 times 40 and 9, I get 1280 and 270 and 18. And this gives me, let me add these up, 1470 and 98, which would be 8, 16, 5, and 1568. And that's just, if I put a decimal here, then that's just under 16, so it makes sense. Here's one of the ones that's a little harder. So it's 0.2 times 0.3. 2/10 of 3/10. So 2 times 3 would be 6, and if I divided that by 10, it would be 0.6, and if I divide that by 10, then it would be 0.06. This one would, it's a little hard to do with estimating, but it is definitely, each of these is less than half, so it's definitely going to be way less than half. Less than half, right? Because 0.5 would be half, and if I'm multiplying something less than half times something less than half, then it's going to be less than half. And 6 times 2, oops, got a little ahead of myself there. 2 times 3 is 6, so my digit is 6, but I need it to be less than half. So 6 is more than half, 0.6 is more than half, 0.06 is less than half. And there are 2 decimal places, so that makes sense. I avoid, a lot of students still struggle with the concept of being 10 times bigger or 10 times smaller. So that's why I don't really often discuss the fact that this is 2/10 and 3/10, and if you have a tenth of a tenth, it's a hundredth, so your answer should be hundredths. If you can understand that, then that is lovely, and you are ahead of the curve right now, but it's still a struggle for a lot of people. For these, I'm just going to go ahead and put in the answers. So once we have our answers all in, D was definitely the hardest one because it is 42 thousandths of 8.5. So 0.5 would be half, which would be a little more than 4. But this is much less than half. It's not just a little bit less than half, it's 10 times less. More than 10 times less than half. So it's going to be way less than 4. So what I end up with is the digits 3570, and to make it work, the decimal needs to go in front of all of those digits. So we get 357 thousandths. And there are 1, 2, 3, 4 decimal places, so that makes sense. And another way that I can check it is that I'm turning this, it's just like dividing by 1,000 almost. So when I think about it that way, this is going to be a really small number. Like I divide by 1,000 and then multiply by 42. So my answer is going to be small. It's going to be less than 1. Here we have about 2 times about 1. So my answer needs to be somewhere near 2. My digits are 1463. 1.463 makes the most sense. And here we have about 10 times 120 is about 1200, and we get the digits 11760, or once you check with your estimate, you realize that 1176 is enough by itself without the 0.0. When kids finished in class, they were allowed to start their homework or to do some puzzle work that was included on the next page. And then their homework was more of the same. So most of them were fairly simple, like this is about 1 times 1, this is about 7 times 6. This one is a little more difficult, but it's less than 1 times 1, so it's going to be a decimal, less than 1. And basically it's half of half. So that's basically it for this lesson. Again, there's a lot of conceptual gaps that I notice in kids when they're dealing with something being 10 times bigger or 10 times less. So estimating can be kind of difficult, but it's very important to have that estimate in place. So if you memorize the rule with the number of times to move the decimal, that is great. That's going to help you, but you need to have those estimating skills in place.